Okay, so up to this point, we have only dealt with three probability distributions. We've dealt with the discrete probability distribution, where typically you're given a table. It could be of probabilities or it could be of frequencies. And then we've talked about the binomial distribution that says there's only two outcomes. And then the Poisson distribution, where we're looking at within an interval. And so here it says a service station has a pump that distributes diesel fuel to employee automobiles. The station owner estimates that only about 3.2 cars use the diesel pump every 2 hours. I have to tell it to, you know what I'm doing, my plan. So this every 2 hours already pretty much tells me that's an interval. So that's my actual, I lost my writing utensil there. That's my interval. Where am I? Okay, interval, which tells me that this is going to be a Poisson. Another thing, there's not an N, a sample size, so I know it can't be binomial, but once again, binomial is only looking at two outcomes. So it says, what is the probability distribution, and how do you know? Well, we just said it's the Poisson, because it has an interval. And then it says define all the known variables. Well, if you remember, a Poisson distribution has lambda, which is the average, and in this case it's 3.2 cars per every 2 hours. And you could even say we're going to have a random variable of the number of cars, because that's our questions that we're going to be interested in. All right, so it says, what is the probability that 3 cars, exactly 3 cars? All right, so we're gonna work this out by hand, so it helps you on the test instead of throwing this in Excel. But I mean, then you could of course go in and throw this into Excel, but I get a little bit worried when it gets time to do this manually, you forget how to do it. So our formula, make sure I got my pen, my ink color's still working here. There we go. So my formula is my lambda. So let's just write it over here. My lambda, so my probability of x, so whatever I'm looking for, is my lambda raised to the x power. Okay, again, lambda being the average. And then e raised to the negative lambda all over x factorial. All right, well, x is 3. We can look up there and we see lambda 3.2 over 2 hours, but this wants it over 1 hour. So if it's 3.2 cars for 2 hours, then if I just simply divide 3.2 in half, then that would actually be the average per 1 hour. So cars per 1 hour. So now I just plug everything in. So I plug in 1.6 to the 3rd power. I plug in e to the negative 1.6 and divided by 3 factorial. Now remember, this means 3 times 2 times 1, the factorial, okay? So if you throw all that in your calculator, so if I put 1.6 raised to the 3rd power, so I get 4.096. So let me write a couple of steps here. 4.096. And then I take e, and I can never find e. There's e. And I raise it to the negative 1.6 power. I get 0.20189. Okay, and you can keep going, however many decimal places. And then I know the bottom is 6. How do I know it's 6? Because I know what 3 times 2 times 1 is. Pretty smart, huh? And so I take the 4096, and now I typically just use my calculator, and I'm just arrowing up to those values. And I multiply the top, and I divide by 6. and I get my probability, which would be 0.1378. So that would be the probability that I would expect, okay, that I would get. I would see 3 cars that will arrive to use the diesel pump during a 1-hour period. All right, then it says, suppose the owner needs to shut down the diesel pump for half an hour to make repairs. However, the owner hates to lose business. What is the probability that no cars will arrive while they have it shut down during this half-hour period? Well, once again, if we started with 3.2 cars per 2 hours, and then we divided by 2 to get it per 1 hour, well, we're going to have to divide it again to get it for the half hour. So divided it in half, and now that becomes my lambda. So I'm looking for the probability x equals no cars, 0. And I just kind of look over in the right-hand corner. The formula says lambda, which is 0.8 raised to the x, 0. E raised to the negative 0.8. And then, if I can get an 8 to write, and then all over 0 factorial. If you remember, we said 0 factorial is the same as 1. Only one way to get nothing to happen. And anything raised to a 0 power is 1. So this basically becomes 1 times, and I just chunked this in my calculator, 4493. All over 1, so you can see the answer is 0.4493. All right, we're moving right along. Okay, so suppose 5 cars arrive during a 1-hour period. So since this is a 1-hour period, I know I'm going back to my lambda of the 1.6. What is the probability 5 or more? So the probability that x is equal to or greater than 5 or more would be the same as 1 minus the probability less than 5. So what I would have to do is I would have to find the probability less than 5, which would be what? The probability 0 plus the probability 1 plus the probability 2 plus the probability 3 and then plus the probability 4. Because we don't really know if you did 5 or greater, then where would you stop? Right? So you do 5, 6, 7, 8. And typically, you know, as I mentioned, once you start getting real small decimal places, you know, you could probably do maybe 5, 6, 7, 8, 9, you know, about that many, and you'd start to see your decimal places start to get smaller and smaller. So if you do this, I'm not going to work this out, but this is the same as part B. So like the first one with 0 would be 1.6 to the 0, e to the negative 1.6 over 0 factorial, then plus 1.6 x. So the only thing that's changing is the x, right? So this 3 becomes 0 plus 1 plus 2 and so on. And if you do that, you should get something along the lines of, I can't find my mouse, along the lines, now I think it took my color away. Why gotta make everything so complicated? 0, hello, oh. I was writing with the wrong end of the pen. 0.0236. Okay, so you really should try to do these manually, okay, to begin with, and then there wouldn't be anything wrong of opening up Excel and, well, you know, if you're taking a test, you can't do it, but opening up Excel and check your answers. Where did Excel go? Did it set Excel? Oh. So slow, so slow. Come on, Excel, open it. You can do it. Open up. And so, as you know, we're going to use the Poisson formula. So the Poisson distribution, maybe I'm not going to open up Excel. You're going to use the Poisson distribution. Close some of these other windows I got going on. And just plug in the formula and you should be able to check your answers. So I guess, oh, I was going to say, I guess I ain't using Excel. This is so slow. I think I just got way too much going. I got it going on, right? All right, so let's just check this real quick. Yeah, I got like probably 15 Excels open, right? Let's just check this real quick. So let me zoom. Yeah. Okay. So the first one, and I'm gonna hard code this in. I'm gonna just type this in, and I know I tell you never do this, that you should actually set up and put your X in, you know, a cell and lambda in a cell, but I'm just gonna type this in because I'm lazy. So I want to do, and I can see it right there as soon as I start typing, and then it says it wants X. Well, my X was 3, and my mean was 1.6 because that's my lambda. I want exactly that value. So false. Look at there. Winner, chicken dinner. Got that answer. Then I can do the one for 0. So equals Poisson distribution. X equals 0. This one, the mean was 0.8 and false. Woohoo! We rolling. And this one now I could you know, number some cells and then sum those up. So let's just do that. 0, 1, 2, 3, 4. And then do my equals Poisson distribution, my X. And I know I said don't do this, but I'm going to hard code the mean, 1.6 and false. So that's the probability of 0. And you might say, but hey, that's not the set. But remember the mean change. I'm dying here. Copy that down. Do 1 minus the sum of those values. Bam! There you go. See? So Excel's cool to do it very quickly, but you need to know how to do it manually. So punch all them buttons in your calculator and see if you get the same answers that I get.